All right, so what's something we noticed? Like, what's a rule either generated or something we're thinking, Will?
With the multiplication ones, you can add the exponents together and then do it.
So multiplication ones, you're saying you think you can add exponents together and do it, okay?
You can add exponents, and then whatever exponent you have at the end, you can just multiply by that exponent.
Okay, so you're saying we could simplify if we had exponent. Do you think we could do that with anything? What about this? Like,
Not with addition.
what about this? What about this?
No.
Yeah.
No.
No, so if they have the same...
So
would it be
Will
scale
is
factor?
saying...
Okay, so basically, if you have, like, let's say you have 3, 2, and then 3, 3, you can add
3
3
squared
and the
times.
2 exponents together because...
Okay, so what you're saying is
scale
if same
factors are
base in all multiplication, you can add exponents. That's what you're saying. Is that a concise...
As long as the bases are the same, yes.
Okay. So what Will's saying is if we have the same basis, it's all multiplication, we can add exponents. Let's test it out. So 6 cubed times 6 squared. If that were true, it would be equivalent to what?
6 in the 5th.
6 to the 5th. Well, guess what? Whoever made this document up has a way for you to check that. And that's right here. 6 to the 5th had the same total. You guys seeing that?
Oh.
Now check this out. Who can explain why that one's also 6 to the 5th?
Because the exponent.
Yeah, Joe.
Because the exponent is 1. It's just.
Joe raised his hand and then I called him. I
Because
appreciate the eagerness.
it's 6 fourths, and then that 6 is basically 6 months, but we don't say that because it's just 6.
Yeah, 6 to the
So
first part.
it's just adding one exponent, so it's 6 fifths.
Cool, so let's test it out. Let's test it out. I'll do a different color. So let's test the same theory out here. So you're saying you can add the exponents, keep the base 2 to the 8th. We're saying it works. As long as I gave you correct patterns, right? Okay. Let's test that out here. Does it hold true there? 4 plus 3 plus 1?
Yes.
Yes.
That's 8. And everything equals 256?
Yeah.
Okay, so let's take a look what happens when we don't have numbers. We have variables, which are numbers, but
I think it can.
1 plus 1 plus 1 plus 1.
Yeah.
Okay, 1 plus 3.
Yep.
Okay, 2 plus 1 plus 1.
Yes.
Now, awesome, we have a rule. And if I give you a worksheet with only problems like this, guess what? You smoke that worksheet, get 100%, no issues, right? Like easy. You're at it.
Light work.
Yeah.
However, I'm going to let you know this unit is one of the hardest units for students who are task-oriented. So what we're going to do now is we're going to explain why it works. Because there's going to be like multiple properties of exponents we're dealing with. And then when we mix them together, kids who are like, oh, I saw a problem like this, I did this, end up messing up. Okay? So we're going to now focus on why this is true. Because the why it's true takes you to what to do, to the algorithm, okay? So follow me with this. We're going to focus on this 6 cubed times 6 squared one, okay? If I were to expand 6 cubed times 6 squared, it would look like this. 6 times 6 times 6 times 6 times 6, right? Mm-hmm. So there's one operation there. 6 cubed times 6 squared only has one factor. What's the factor? I mean, it has more than one factor, but what's the base factor? 6. I have 3 of them and 2 of them for a total of 5 of them. That right there is why we can add the exponents, okay? So let's look at this one right here, the 2's. 2 to the 4th is 2 times 2 times 2 times 2. 2 to the 3rd is 2 times 2 times 2 times 2. That whole thing's just times 2's. Does everybody see that? If you imagine it. Now don't expand it out. That's a ton of work. But if you can imagine what it means to expand it out, I just have all these factors of 2 for a total of 8 factors of 2. That's why it works. That's why we can add the exponent. Cool? Do you see how, like, if you understand why it works, then you know to add?
Wait, what's the?
What is that?
It's not 8 factors.
Yeah.
It is. 4 factors of 2, 3 factors of 2,
That's a 3.
1 factor.
3 out of 5.
Yep. So let's expand our algorithm now to those 2 on the bottom. So if it's true, x squared times x to the 6 should equal x. What do you think's the most common wrong answer there?
Probably 12x.
X to the 12th is the most common wrong answer. Right?
Yeah.
There's not 12 factors of x. There's an x times 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 x. That's all just multiplication for a total of 8 factors of x. Now 12 looks different, I know it, I did this on purpose. And we're not even doing negative exponents yet. However, when we have the same base, what can I do with my exponents if it's all multiplication? Add, so let's add it. Negative 4, negative 2 is?
Negative 6.
Negative 6 and 8 is?
2.
So y squared. The same rule works. What's cool is if you get that wrong, it's all right. That's a good one to get wrong, right? Cool. That is called, let's write it somewhere on here. I got a lot going on my page.
Okay, what about
That
the
is called
addition,
the product rule. So if you see that on something, that is the product rule of exponents. Now, what if you do have addition? You guys notice I slapped that one on there? And it didn't have the same answers, right? So when it's addition, you can't just add the exponents. The reason is, it's not all multiplication. It's not all the same operation. So if you were going to do this, you'd have to do this and this independently because of the order of operations and then add them together. So that would be like, if I asked you to simplify that thing, the simplest way you could have a base and exponent with that would be 6 squared plus 6 cubed. You can't do anything with it. I mean, you could solve for 252, but base exponent wise, you can't squish your bases or anything there. Mikey is saying this right here, which is called the power rule. Okay? He's saying, in this case, multiply exponents. So let's test that out. Okay? So, x to the 6 squared, 6 times 2 is 12. Checks out. All right? 3 to the 3rd squared, if that's true, would be 3 to the 9th. 3 to the 9th would be 729.
Correct.
Sorry, not to the 9th, 6. You guys saying correct. 729, 729, so it's 3 to the 6th. Looks like it checks out.
Big pomegranate.
Okay. Now, I want to look at number 3 with you.
Yeah.
Yeah. That's a sound from scratch. Okay. So let's go to why this works. You know, because do you guys see like you're going to be tempted to add one of these times, multiply the other, and if you're trying to memorize, you're going to mess that up probably over time. You guys kind of seeing that? So let's talk about why this works. I'm actually going to start with number 2 first for why it works. X to the 6th squared means x to the 6th times x to the 6th, correct?
Yeah.
So how many factors of x are there?
12.
12. That's why you can do 6 times 2. So if you think about what it means expanded, it brings you to the multiply. Because otherwise you're going to be tempted to multiply sometimes, add other times, you're going to mess up when to do what. So let's look at the 4x squared. I'm going to actually do that over here where there's a little more room. 4x squared literally means 4 times x times 4 times x. And if it's all multiplication, the commutative and associative properties say order doesn't matter. So what can I multiply there that would give me that 16?
4 times 4.
4 times 4 is the 16, and then x times x is my x squared. That's why it's 16x squared.
Yeah.
So I wouldn't, I'm just showing you what it looks like expanded. I wouldn't expand it out. What my mind kind of does here is says, I need to square the 4 and I need to square the x. Remember, 4 and x aren't like one thing. They're not magically attached. 4x is 4 times x. They're like independent things, kind of. They're one term, but they're independent things. 4 times x. A lot of times, students for that one will write 4x squared. But you're not squaring 4x then. You'd only be squaring your x. All right? So, as Mikey kind of, spoiler alert, you know.
Spoiler alert, I'm really sorry.
It's all right. He said x squared to the 8th. If we extend that rule, a power to a power, we multiply. That would be x to the 16th. Okay? So the power rule, we can multiply exponents because it's a power to a power. We're getting our factor, our base factor of something to a power that many more times. To keep it straight, think about what it means, okay? I'm going to promise you it's difficult if you're like, these ones I do this, these ones I do this, and you don't understand why. It's going to be different. You're going to mix them, all right? Next, I want to look at number 10 on the homework with you. Let me get that set up there. All right, let's look at number 10 together. Are you seeing that number 10 looks extra? So, to do number 10, I'm going to show you what it would look like expanded over here. And over here, I'm just going to show you just what I would get for an answer, what I'd go right to. So if I expanded number 10, I've got 3x squared squared, which means I have base 3x squared how many times?
Does that mean life is shorter?
I have 3x squared as a base how many times? 2. It's squared. Which would kind of be like, don't write this, but it'd kind of be like 3x squared times 3x squared, right? That's what 3x squared means. And if I did 3x squared times 3x squared, I could simplify that as 9x to the fourth. Does everybody get 9x to the fourth there? 3 times 3 is 9. X squared times x squared is x to the fourth. Then I still have, though, a times 6x
Why did Mr.
to the fourth.
I never upload this class?
Okay? So I got 9x to the fourth times 6x to the fourth. Be mindful that nothing's like, these aren't just two things. This whole thing, if I were to expand it out, would be this. 9 times x times x times x times x times 6 times x times x times x times x.
Boring.
Right? I can rearrange this any way I want. So that's why I would rewrite it as 54x to the 8th.
It's 9 times 6.
9 times 6. I can't, right? If it's all multiplication order, it doesn't matter. I can do 9 times 6. So I'd get 54 to the 8th for that. Now, here's how I would just go about that. What I like to do is I kind of like distribute my exponent. I've got 3 squared is 9, x squared is x to the 4th, times 6x to the 4th. And me here, I don't need to expand here. I know this is all just multiplication. 9 times 6 is 54. 4 factors of x and 4 factors of x is 8 factors of x. So that's kind of just like how my brain works through it. If you just try to memorize when to add and when to multiply, you're going to have a struggle. Lean on the what does this look like if I expand it? Because that'll make you have those extra factors if you need to multiply. It'll make you not multiply when you should be adding because you're just understanding that this means this many factors. Cool. This is your homework. It's on Canvas. You go to do it on lined paper. It's due Monday. All right. I did one of them, so you only have 11. In some of these guys, with the way exponents work, sometimes we get a couple wrong. It's all right. We're going to go over them together on Monday to make sure you're all set.